Mastery Practice Chapter 6. Questions number 1. Express the following nonlinear equations in the linear form y equal to mx plus c such that x and y are variables, m and c are constants. So first, the capital Y here can only contain the variables either x, y or x and y, where on your right hand side you can only have one term which contains the variables and the other terms will just be a constant. Now for questions A, y equal to 3x plus 4 over x squared. So on the right hand side you have two terms which contains the variables. So we can only have one. Therefore, to achieve that, I'm going to divide first every terms with x. By doing that, I'm going to get y over x equal to, so 3x divided by x, the x here will be cancelled. You're just going to have number 3. And when 4 over x squared you divide by x, is the same meaning as you multiply it with 1 over x. Therefore, you're going to get 4 over x cubed. Now, I'm going to rearrange this. So, it's going to be y over x equal to 4 over x cubed plus 3. Next, for the 4 over x cubed, I can write it as 4 times 1 over x cubed. Now, when I compare it with the y equal to mx plus c, my capital Y will be y over x, my m is 4, the capital X is 1 over x cubed, and c is equal to 3. Now, there is another way of doing this. I can also multiply each terms here with x squared. Now, by doing that, I'm going to get x squared y equal to 3x cubed. When 4 over x squared times x squared, this will be cancelled. Therefore, you're just going to get plus 4. Now, when I do this straight away, I already convert it in the linear form. Now, by doing the comparison, my y, capital Y, is going to be x squared y. My m is 3. My capital X will be the x cubed, and the c will be equal to 4. That is for questions A. Now, for questions B, y equal to px cubed plus qx squared. Now, on the right hand side, you have two terms which contains the variable x. Now, to get rid of one of them, first I'm going to divide every terms with x cubed. So what I'm going to get next is y over x cubed equal to, so here the x cubed over x cubed will be cancelled. Straight away I'm just going to get p plus, so here when I cancel it, I will get q over x. Now, if I do rearrangement here, I'm going to get q over x plus p. Now, I can write the p over x as q times 1 over x. Now, when I do comparisons with the y equal to mx plus c, my capital Y will be y over x cubed. My m is equal to q, and my capital X is 1 over x, and c will equal to p. So there is another way for us to do this. I can also divide every terms with x squared. By doing that, I'm going to get y over x squared plus, so here when I cancel it, I will just get px. And here the x squared will be cancelled. It will be just plus q. Now, this already written in linear forms. By doing the comparisons, my capital Y will be y over x squared my m is equal to p, my capital X is just the X, and my c is equal to q. Question C, y equal to p over x plus q over px. Now on the right hand side, I have two terms containing the x, so I need to get rid of them. To do so, first I'm going to divide every term with x. By doing that, I'm going to get y over x equal to, so when p over x you divide by x, is the same meaning as you multiply it with 1 over x. So you're going to get p over x squared plus, so here the x will be cancelled, you're just going to get q over p. Now the p over x squared, I can write it as p times 1 over x squared. Now by doing the comparisons, my capital Y will be y over x, my m is p, my capital X is 1 over x squared, and the c will be q over p. So there is another way to convert this nonlinear to linear form. I can multiply each terms with x. By doing that, on my right hand side, I will also just get one variable x. So here I'm going to get xy equal to, so the x here will be cancelled, you're just going to get the p, and here you're going to get q over p x squared. So I'm going to rearrange this. Now by doing the comparisons, my capital Y will be the xy, my m is equal to q over p, my capital X will be x squared, and the c will be the p. Now let us move to questions D. Y equal to pk to the power of square root of x. Whenever you have two combined terms, in this case pk, you can always separate them by using the logarithms. So first we're going to take logarithm to the base of 10 on both sides. Therefore you're going to get log base 10 of y equal to log base 10 of pk to the power of square root of x. Next, on the right hand side, you can use the product law to separate them. So I'm going to get log base 10 of p plus log base 10 of k to the power of square root x. Next, using the power law, I can move the power here to the front. So it's going to be square root of x times log base 10 of k. Now I'm going to do a little bit arrangement here. So log base 10 of y equal to log base 10 of k times square root of x plus log base 10 of p. Now by doing the comparisons, my capital Y will be the log base 10 of y, my m is log base 10 of k, my capital X will be the square root of x, and the c will be the log base 10 of p. Questions E, y equal to pk to the power of x minus 1. So this is the same as the questions D before, as you have two combined terms, which is the pk, so you can separate them by using the logarithms. Again, take logarithms to the base of 10 on both sides, so you're going to get log base 10 of y equal to log base 10 of pk to the power of x minus 1. Next, on the right hand side, you can separate them using the product law. So it's going to be log base 10 of p plus log base 10 of k to the power of x minus 1. Next, using the power law, I can move this x minus 1 to the front. So it will be x minus 1 times log base 10 of k. Now I'm going to do a little bit arrangement here. So it's going to be log base 10 of y equal to log base 10 of k times x minus 1 plus log base 10 of p. Now, by doing the comparisons, my capital Y will be the log base 10 of y, my n is going to be log base 10 of k, and my capital X will be the x minus 1, and the C will be the log base 10 of p. Now, for questions F, y equal to k to the power of x squared over p. Again, you have the combined terms here, the k and p. So here we can separate them also using the logarithm. So first, we're going to take log of base 10 on both sides. So log base 10 of y equal to log base 10 of k to the power of x squared over p. Now, on the right hand side, using the divisions law, I can separate them. So I'm going to get log base 10 of k to the power of x squared minus log base 10 of p. Next, using the power law, I can move this x squared to the front. So it will be x squared times log base 10 of k minus log base 10 of p. Now I'm going to rearrange this. So it's going to be log base 10 of k times x squared minus log base 10 of p. Now, by doing the comparisons, my capital Y will be the log base 10 of y, my m will be the log base 10 of k, and the x will be the x squared, whereas my c will be the negative log base 10 of p. Questions number 2. The variables x and y are related by the equations y equal to px squared plus qx, such that p and q are constants. The diagram on the right shows parts of the line of base fit obtained by plotting the graph of y over x against x. So A, convert the equations y equal to px squared plus qx to the linear form. So for questions A, to convert this nonlinear to linear form, we have two options. One of it is that we divide every term with x squared. Another will be dividing every term with just x. So how do we know which one is the correct one? Then we need to look at the graph. So from the graph that being plotted, which is the linear, the variables on the y-axis, which is the y over x, this is the capital Y. And the variables on the x-axis, this is the capital X. So from here we know that the capital Y will be y over x. Therefore, using this clue, we're going to divide every term with just x. By doing that, you're going to get y over x equal to, so here we can cancel the x, so we're just going to get px plus, so the x here will be cancelled, plus q. Now, by doing the comparisons, the capital Y will be the y over x, the m is the p, capital X is the x, and the c will equal to q. So for questions B, finds the value of P and Q. Now, by doing the comparison, the P is actually referred to the M, which is the gradient. And from the graph here, we already know two coordinates here. Therefore, we can find the P, which is the gradient, by using the formula y2 minus y1 over x2 minus x1. So here it will be 5 minus 3 over 1 minus 9. So you're going to get 2 over negative 8. Simplify this, you will find that it is negative 1 over 4. That is the value for P. Now we want to find the Q. So the Q here is actually the y-intercept. Now, as we already know what is the gradient. So the equation will be y over x equal to negative 1 over 4 x plus q. To find the y-intercept, you can take any coordinates that you know on the straight lines. For example, in this case, I'm going to choose 1 and 5, and then I'm going to substitute it into the equation itself to find the q. So from here, the number 1 is actually the coordinate x, and this number 5 is actually the coordinate for the y over x. Therefore, the y over x here, I'm going to substitute it with number 5. And for the x here, I'm going to just substitute it with 1. So next, I'm going to move this negative 1 over 4 to the right hand side. It will be 5 plus 1 over 4 equal to q. Therefore, q is equal to 5 and 1 over 4, which is equal to 5.25. Questions number 3. The variables x and y are related by the equations y equal to px to the power of x squared over 4. The diagram on the right shows parts of the lines of base fit obtained by plotting log base 10 of y against x squared. Finds the value of p and q. So first, we're going to convert the nonlinear equations y equal to px to the power of x squared over 4 into the linear form. Now, based on the graph that being plotted, the capital Y will be the log base 10 of y, and the x squared will be the capital X. So as this involving the logarithms and the combined term, so first we are going to take log with the base 10 on both sides. So first, it's going to be log base 10 of y equal to log base 10 of pq to the power of x squared over 4. Now, on the right hand side, using the product law, I can separate them. So it's going to be log base 10 of p plus log base 10 of q to the power of x squared over 4. On the right hand side here, using the power law, I can move this x squared over 4 to the front. Now I'm going to rearrange this. So it's going to be x squared over 4 times log base 10 of q plus log base 10 of p. Now, if you look at the graph that we have here, the capital X will be the x squared. So I'm going to do a little bit of arrangement here. So x squared over 4, we can write it as x squared times 1 over 4. So I'm going to write this as 1 over 4 times log base 10 of q, and whereas I'm going to move the x squared to the back there. Now, by doing the comparisons, my capital Y is the log base 10 of y, whereas the m is 1 over 4 log base 10 of q, and the capital X will be the x squared, whereas the c will be the log base 10 of p. So the questions here is asking you to find the value of p and q. So first, we're going to find the q. So the q here, which is 1 over 4 log base 10 of q, we know that this is equal to the gradient. So we already have two coordinates on the graph, so we can definitely find the value of the gradient. So 1 over 4 times log base 10 of q, this is equal to gradient. So using the formula y2 minus y1 over x2 minus x1, so it is 5 minus 4 over 6 minus 4. So 1 over 4 log base 10 of q equal to 1 over 2. Next, I'm going to move this 1 over 4 to the right hand side. It's going to be log base 10 of q equal to 1 over 2 times 4, which is equal to 2. Now, you can solve this using your calculator, or you can just convert it into the index form. So it will be q to the power of q equal to 10 to the power of 2. Therefore, q is equal to 100. So next, we want to find the value of p. All right. So p is the log base 10 of p, which we know is the value of c, which is the y-intercept. So now we already know that the gradient is equal to 1 over 2. Now the equations will look like this. Log base 10 of y equal to the m 1 over 2 x squared plus log base 10 of p. Now to find the y-intercept, as long as you know one coordinates on that straight line, you can just substitute it into the equations now. So here we have 6, 5, and 4, 4. I'm just going to choose the 4, 4. So here the 4 here is the value for the x squared. And the other 4 here is the value for the log base 10 of y. So here the log base 10 of y, I'm going to substitute it with 4. The x squared with 4 as well. So p is the y-intercept. So here I can simplify it. And then you're going to, so 4 equal to 2 plus log base 10 of p. Then move this 2 to the other side. So log base 10 of p equal to 4 minus 2, which is equal to 2. Now again, you can just solve this using your calculator. Okay, I can just convert this into index form. So p equal to 10 to the power of 2. So p equal to 100. Questions number 4. The diagram on the right shows parts of the lines of base fits of y over x against x. Given y equal to 5x minus 3x squared, finds the value of k and h. So first, we're going to convert the nonlinear to the linear forms. So based on the graph that being plotted, the y-axis, which is y over x, is the capital Y. And for the x-axis, the x is for the capital X. Now, based on the clue that I have here, to convert the nonlinear to the linear form, I'm going to divide every terms with x. By doing that, I'm going to get y over x equal to, so the x here will be cancelled, so it's going to be 5 minus 3x. Now, by doing a little bit of arrangements, here I'm going to get negative 3x plus 5. Now, by comparisons, the capital Y is the y over x, the m is the negative 3, the capital X is the x, and whereas the c, the y-intercept is equal to 5. So here we want to find the value of k and h. Now, for these equations, we already know the gradients and the y-intercept. To find the value of k here, as we already know one of the coordinates, we can just substitute it into the equation itself. So the equations that we have for the linear forms is y over x equal to negative 3x plus 5. Now, this number 2 is the x coordinate, whereas this k is the coordinates of the y over x. So for the y over x, I'm going to substitute it with k, and the x, I'm going to substitute it with 2. Now, solve this, you will find that the k is equal to negative 1. As for the h and 3, for these coordinates, we can just use the same method. So y over x equal to negative 3x plus 5. Again, this h is for the x coordinates, and this 3 is for the y over x coordinates. So y over x, you just substitute it with 3, whereas the x, you got to substitute it with h. So I'm going to move this negative 3h to the left hand side. So positive 3h equal to 5 minus 3. So h is equal to 2 over 3. Now, if you look at the k and h that we find, there is definitely something wrong with the diagram that is being plotted here. Why? Because if you look at the k here, is above the x-axis, definitely is going to be a positive one, but we get a negative one. So supposed to be the 2k, the point should be here, someplace again here. So 2, negative 1. And as for the h, the value is 2 over 3. So it will be before the coordinates 2. So it should be probably something like here. And this should be the graph look like. Questions number 5. The diagram on the right show parts of the graph of y against x for the equations y equal to ab to the power of x such that a and b are constants. A. Sketch the straight line graph of log base 2 of y against x. So there is a mistake inside the textbook. It stated there is the log base 10 of y, but it's supposed to be log base 2 of y. Later on, mark and state the coordinates of the corresponding point P and Q. So the graph that being shown here is the non-linear one. So we want to convert this into the linear forms. So first, for the point P, for questions A, for the point P, after it is being converted into the linear form, which is log base 2 of y against x, as the coordinate x still going to be x after it's being converted. So when the coordinate x of the P for the nonlinear is equal to 1, after the conversion, it will still remain as 1 as well. But for the coordinate y, which is the 4 for the nonlinear, after you convert it into the linear form, we need to substitute the coordinate y, which is 4, into the log base 2 of y. So it will become log base 2 of 4, which is equal to 2. Therefore, the coordinates of the point P after it is being converted to the linear form, the coordinates will become 1, 2. And as for the point Q, the x coordinate after it's being converted will still remain the same as 3. But for the coordinate y, it will become log base 2 of y. So we're going to substitute the 32 into log base 2 of y. Therefore, you're going to get the answer of 5. Therefore, the coordinates of q after it's been converted, it will become 3, 5. So now we can plot the graph. So for the y-axis here, this is going to be the log base 2 of y. And for the x-axis, is going to be x. And the point P, which is 1, 2, so probably here. And for the Q, which is 3, 5, okay, I'm going to plot it here. So now let us just connect these two dots. So this will be the graph look like for the log base 2 of y against x. So questions B, based on the graph in A, finds the value of A and B. So first we need to know the variable A and B represent what. Therefore, we need to convert the nonlinear equations y equal to abx into the linear form. As this involving the log, based on here, we know that the log base 2 of y is the capital X, whereas the x-axis, the x is the small letter x. Therefore, y equal to abx. As this involving the log, we need to take log with the base 2 on both sides. So log base 2 of y equal to log base 2 of abx. Now on the right hand side, using the product law, we can write it as log base 2 of a plus log base 2 of b to the power of x. Now again, using the power law, we can move the x to the front, so it's going to be x times log base 2 of b. Next, I'm going to rearrange this, so this will become log base 2 of b times x plus log base 2 of a. Now, by doing the comparisons, you'll find that the capital Y, which is the log base 2 of y, the m is the log base 2 of b, the capital X is the x, whereas the c is the log base 2 of a. So now we're going to find the value of a and b. So first we know that the log base 2 of b is equal to the gradient. So from the linear graph here, we have two coordinates. So we're going to use this to find the gradient. So first, log base 2 of b equal to, so using the formula y2 minus y1 over x2 minus x1. So 5 minus 2 over 3 minus 1. So log base 2 of b equal to 3 over 2. So next, if you want to use calculator to solve this, it also can, or you can convert this logarithm form into index form. It's going to be b equal to 2 to the power of 2 over 3. So using your calculator, you're going to find that the b is equal to 2.828. Now, we want to find the a, so log base 2 of a is equal to c. Now we already know the gradient is equal to 3 over 2. Now substitute it back into the equation that we already convert. You're going to find that the equations will be log base 2 of y equal to 3 over 2 x plus log base 2 of a. Now to find the y-intercepts, so we just need to use one of the coordinates. So here I'm going to choose the p, 1 and 2. So the number 1 here is the x coordinate, whereas this number 2 is the log base 2 of y coordinate. So for the log base 2 of y, I'm going to substitute it with 2. And the x, I'm going to substitute it with 1. So log base 2 of a here is equal to 2 minus 3 over 2. The answer is equal to 1 over 2. Now, you can solve this using your calculator, or you can convert it to the index form. So a equal to 2 to the power of 1 over 2. Using your calculator, you'll find that a is equal to 1.414. Questions number 6. When x squared y against x are plotted, a straight line is obtained. The straight line has a gradient of 8 and it passes through points 2, 19. So A, determine the equations which relates x and y. B, hence finds the value of y when x equal to 9.4. So first, I'm going to plot the graph x squared y against x, so you can see it's clearly what is happening here. So probably the graph look like this. With the y-axis here is the x squared y, whereas the x-axis is the x. So this is straight line with the gradient of 8 and is passing through a point which is equal to 219. So let's say this is the point 219. So first we want to create the equations for this linear form. So the y-axis here is the capital Y and the x-axis here is the capital X. So from here we know that y equal to mx plus c for the linear forms. So the y here we're going to replace it with x squared y. The m is the gradient. We know that the gradient is equal to 8. So I'm going to substitute the 8 for the m. The x is the small letter x plus c. So now we're just lacking the informations of the y-intercept. But we know that this straight line passed through this point 2, 19. So this number 2 is for the x coordinate. And then this 19 is for the x squared y coordinates. So to find the c, I'm going to substitute the 19. So it's going to be x squared y, substitute it with 19. As for the x, substitute it with 2. So c equal to 19 minus 16. Therefore, c is equal to 3. So now we know the c, so we're going to substitute it into the equations. So x squared y equal to 8x plus c. So the questions A is determine the equations which relate x and y. So we want to find the non-linear one with the y as the subject of the formula. Therefore, we're going to move the x squared to the other side. Therefore, y equal to 8x plus 3 over x squared. As for questions B, hence finds the value of y when x is equal to 9.4. As for questions B, we're going to use the formula here. And to find the y, we're going to substitute the x with 9.4. So y equal to add x. So the x substitute it with 9.4 plus 3 over 9.4 square. So this one, just solve it using a calculator. You'll find that the y is equal to 0.8850. Question number 7. A study is conducted to determine the relations between the mass M and the volume V of a type of cooking oil. The following table shows the result of the study. So plot the graph of M against V by using the scale of 2 cm to 1 unit on both axes. So hence draw the lines of best fit. So the graph is M against V. Therefore, the M will be on the y-axis and the V will be on the x-axis. So first, let us plot the scale. So next, we want to mark the points accurately on the graph. Next, we want to draw a line of best fit, which is a straight line that passes through as many points as possible. If there is any point that is not on the straight lines, so we need to make sure this point should be almost equally distributed on both sides of the straight lines. So this is the line of best fit that we got, and we have one point that is not lie exactly on the straight line. This is due to the presence of errors in measurements during the experiments. Questions number 8. Based on an experiment, the relation between the values of x and the value of y are shown in the table below. So A, plot the graph of y against x and draw the lines of best fit by using a scale of 2 cm to 10 units on the x-axis and 2 cm to y units on the y-axis. So B, hence form the equations of the straight lines. So first, let us plot the scale. We want to mark the points given in the table into the graph. Next, we're going to draw the lines of the best fit. So this is the graph of y against x look like. So B, we want to form the equations of the straight lines. So the equation of the straight line is y equal to mx plus c. So first we need to find the information about the gradient, the m, and also the y-intercept, c. So first we're going to find the gradient, which is the m, using the formula y2 minus y1 over x2 minus x1. So here we need to find any 2 points that is on the straight lines. So the points that I'm going to choose will be, one of it is going to be this point. Another points that I'm going to choose is just going to be the y-intercept. So first let us find the coordinates first. So the gradient will be 35 minus 12.5 over 60 minus 0. So solve this, you're going to get the answer is equal to 3 over 8. So that is the gradient. And these points here is the y-intercept, which is the c. So here we know that the c is equal to 12.5. Okay, you can write it in fraction form, then it's going to be 25 over 2. So now we already have the informations of m and c. So now we want to form the equations of the straight line. So again, remember y equal to mx plus c. So the y-axis here is the y, so it's going to be just y, and the m is 3/8, and the one that is on the x-axis will be the x, so it's just going to be x, and our c is 12.5, or you can just write it as 25/2. So that will be the equations of the straight lines. Questions number 9. The table below shows the values which relates the temperature, capital T, of a solution after time, small letter t, in an experiment. So A, plot the graph of the temperature against times. Hence, draw the lines of best fit by using suitable scale. So first, let us plot the scale. So the scale that I choose will be 2 centimeter to 5 units on the y-axis, which representing the temperature, and 2 centimeter to 2 units on the x-axis, which representing the times. So next we want to mark the points given in the table into the graph. So next we want to draw the lines of best fit. So this is the lines of best fit that I got, as is passed through most of the points. Now questions B. So mark an X on the graph, the point which was recorded wrongly, then finds the correct value for the T degrees Celsius. So the one that is marked wrongly will be the one that is T, the times of 4 seconds and the temperature of 40. So here is the one, so we're going to mark this and finds the correct value. So the correct value should be the one that is on the straight line that we plot. So here should be the correct value. So the correct value here for the T should be 30 degrees Celsius. Question C. From the graph, find number 1, the initial temperature of the solution. So the initial temperature is the temperature of the solutions when the experiment started. So it will be at the T equal to 0, the times equal to 0. Therefore, it means it is the y-intercept in this case. So if you look at the y-intercept, which is here, the temperature will be equal to 28 degrees Celsius. Number 2, the temperature of the solutions after 9 seconds. So here I'm going to plot the straight lines. So at the 9 second, based on the straight line that we will plot here, you're going to find that the temperature is equal to 32.5 degrees Celsius. Number 3, the time taken for the solutions to reach a temperature of 30.5 degrees Celsius. Again, on the graph, we're going to draw a straight lines at the temperature of 30.5 degrees Celsius. From the straight line that we plot on the graph, you're going to find that the time taken after the temperature reached 30.5 will equal to 5 seconds. Questions number 10. The table below shows the value of two variables, x and y, obtained from an experiment. The variable x and y are related by the equations y equal to st to the power of x, such that s and t are constant. So A, plot the graph of log base 10 of y against x by using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 0.1 unit on the log base 10 of y-axis. Hence, draw the lines of best fit. So before that, first we need to find the value of the log base 10 of y for each of the value given in the table. So to do that, we are going to take the value of y given in the table and substitute it into the log base 10 of y. So the first one here is going to be log base 10 of 2.51, which is equal to 0.40. So we're going to take 2 decimal places for the value that we convert here. And the second one will be 0.51, followed by 0.64, 0.76, 0.89, and 1.00. So now we are going to plot the graph. First, we're going to draw the scale. Now we can mark the points given in the table into the graph. Now we're going to draw the lines of best fit. So this is the straight lines of the lines of best fit, as this is the straight line that pass through most of the points, and we have 2 points that is not on the straight lines, and it is equally distributed, one on the upper sides of the straight line and one on the lower sides of the straight lines. B, from the graph, finds the value of number 1, the s, number 2, the t, and number 3, x, when the y is equal to 4. So first, from the graph that we plot here, the y-axis is the log base 10 of y. So this is the capital Y, whereas the x-axis is the small x here. So this will be the capital X. So we need to convert the nonlinear equations given here into the linear form that is in the graph. So as this involving the logarithms, and we have the combined terms here. So first we're going to take log base 10 on both sides. So it's going to be log base 10 of y equal to log base 10 of st to the power of x. Next, on the right hand side, using the product law, I can write this as log base 10 of s plus log base 10 of t to the power of x. So next, using the power law, move this x to the front, so you're going to get x times log base 10 of t. So I'm going to arrange this. So this will be log base 10 of t times x plus log base 10 of s. Now we're going to do comparisons with the y equal to mx plus c. So from here we know that the m is the log base 10 of t, and the s and the log base 10 of s is equal to c, which is the y-intercept. So for the first questions here, finds the value of s. So number 1, so we know that the log base 10 of s is the y-intercept. So based on the graph, here is the locations of the y-intercept. And here, if you read this, the y-intercept is equal to 0.28. So log base 10 of s is equal to 0.28. So to find the s, here you can use the calculator to solve this, or you can convert it into index form. So s is equal to 1.905. Number 2, the t. So from here we know that log base 10 of t is equal to the gradient. So we're going to find the gradient from the graph. So we need to take 2 points which on the straight lines that we draw here. So the first point, I'm going to take this point, and the other points I'm going to take the y-intercept. So here the coordinate of this point is going to be 9, 1, and the coordinates of the y-intercept is 0 and 0.28. So we're going to find the gradient using y2 minus y1 over x2 minus x1. So here the gradient is going to be 1 minus 0.28 over 9 minus 0. Solve this, you're going to find that log base 10 of t equal to 2 over 25, which is the gradient here. So here you can solve the t using your calculator, or you can convert it into the index form, which is 10 to the power of 2 over 25. Solve this, you're going to find that the answer is equal to 1.202. Number 3, x when y equal to 4. Now, from the graph here, we don't have the value of y, but we have the value of log base 10 of y. So using the graph here, I need to convert the y into log base 10 of y. So log base 10 of 4, which is the y value y given here, this is equal to 0.6. So from 0.6 on the graph here, on the axis of the log base 10 of y, I'm going to draw a straight line to find the value of x. So from the straight line that we plot here, we're going to find that when the y is equal to 4, the x is also equal to 4. Questions number 11. The table below shows the value of two variables x and y obtained from an experiment. The variables x and y are related by the equations 2y minus p equal to q over x, such that p and q are constant. So A, plot the graph of xy against x by using a scale of 2 cm to 1 unit on the axis and 2 cm to 2 unit on the xy axis. Hence, draw the lines of best fit. So first, according to the graph xy against x, so first we need to find the value of xy. To find the value of xy, we're going to multiply the value of x and y given in the table. So the first one here, we will get 1 times 5, which is equal to 5. 2 times 3.5 is equal to 7. And 3 times 3.1, you're going to get 9.3. Whenever you're going to get a decimal, make sure you write it up to 2 decimal places. So here I'm going to put 9.30. 4 times 2.7 is 10.80. And here this one is going to be 13. And 6 times 2.5 is equal to 15. So now we're going to plot the graph. So this is the lines of best fit that we're going to get, and we're going to have 2 points which is not going to lines on the straight lines, and it is equally distributed. Questions B. Use the graph in A to find the value of number 1 p, number 2 q, and number 3 y when the x is equal to 3.5. Now, based on the graph, the linear one that we plot here, the capital Y will be the xy, whereas the capital X is the small letter of x. So we want to convert the non-linear, which is the equations given here, into the one that we plot in the graph. So to get that, so the equation is 2y minus p equal to q over x. As our capital X contains xy, so here I'm going to multiply, first I'm going to multiply each terms with x. By doing that, I'm going to get 2xy minus px equal to, the x here will be cancelled, then it will be equal to q. So next, I'm going to move this negative pq to the right hand side. So 2xy equal to px plus q. And you need to remember that the capital Y, which is the xy, can only constant the variables. So we have the coefficients of 2 here, which we need to move to the right hand side. Therefore, xy equal to px over 2 plus q over 2. Now, I can write the px over 2 as p over 2 times x. Now, when you do comparison with y equal to mx plus c, you are going to find that the m is equal to, the gradient is equal to p over 2. And the c, which is the y-intercept, is equal to q over 2. So to find the P for the questions number 1, we know that the P over 2 here is equal to the gradient. So we're going to take 2 points that is on the straight line that we plot here to find the gradient. So the first point that I'm going to pick is this one. Another one will be just the y-intercept. So the coordinates of this point here will be 6, 15, and for the y-intercept is going to be 0, 3. So here the gradient will equal to 15 minus 3 over 6 minus 0. So P over 2 here will equal to 12 divided by 6, which is equal to 2. To find the P, move these 2 to the right hand side. It will be 2 times 2. Therefore, P is equal to 4. Next, we want to find the value of Q. So from here, we know that the Q over 2 is the y-intercept. And from the graph that we plot here, the y-intercept is equal to 3. Therefore, what is the value of Q? Is equal to 2 times 3, which is equal to 6. Number 3, the value of y when x is equal to 3.5. So here I'm going to plot the straight lines on the graph for the x equal to 3.5. From the straight line that we plot here, we're going to find that when x is equal to 3.5, the value that we get on the y-axis here is equal to 10. And this number 10 that we find here is the value for the xy. So xy is equal to 10. Now, we know that the x is equal to 3.5. To find the y, we're going to substitute the x here with 3.5. Therefore, y is equal to 10 divided by 3.5. You're going to find that the y is equal to 2.8571. Question C, calculate the value of x when y equal to 50. So this one we can straight away using the calculations from the equations given. Or you can use the equations that you already convert in questions B. So if you're using the equations from the questions B, you're going to find that xy equal to p over 2x plus q over 2. So the p over 2, which is the gradient, equal to 2. So it's going to be 2x plus q over 2 is equal to the y-intercept, which is equal to 3. Now, to find the value of y, the x, so now I'm going to substitute the y equal to 50. So x times 50 equal to 2x plus 3. So here you're going to have 50x minus 2x equal to 3. So 48x equal to 3. So x equal to 3 divided by 48. You'll find that the value of x is equal to 0.0625.